And for FTC part 1, we said if we are given a function in the form of an integral from f of t dt. So notice that if I have x here, which is this x, the independent variable, I cannot have f of x and dx here. So notice that. So part 1 only says that if you differentiate this side and differentiate this side, your answer will be that g prime of x equals f of x. That's all it says. But I want to caution you here on one thing. It should say times the inner function prime. Why don't we use this? Because this is the inner function. Okay? This is the inner function inside the integral. But why don't I need to write x prime? Is anyone with me? Hello?
Sorry, can you repeat the question?
Yes. So when I differentiate this side, I have to differentiate this side. So g prime is here. When I differentiate an integral, the symbol disappears. The integral symbol and dt will disappear. And then all I have to do is just plug this function in. But I should write times the inner function prime. Why don't I write this? Why do I skip this?
Because it's 1.
Exactly. But notice the difference now. If I'm given g of x as the integral from a to t of x, not just plain x whose derivative is 1, but a function of x from f of t dt, the whole thing changes. So when I differentiate the left-hand side and I differentiate the right-hand side, the left-hand side will be g prime of x. The right-hand side has to be f of t of x. But because t of x prime is no longer 1, I have to multiply by the inner function prime. So that's our first note or caution. The second caution is this must be a number. No x, no function of x. Okay, these are absolutely mandatory conditions. So the lower limit has to be a number. It cannot be x or a function of x. The upper limit can be anything. It can be plain x. It can be a function of x. Of course, it cannot be a number, because if I have a number here, then the derivative will be 0. So the upper limit has to be either x or a function of x. Okay, so now I have this first example that I did not get the chance to show you. So I'm going to copy g of x. I don't remember if we made it up or one of you made it up. It doesn't matter. The integral from a to sine x f of t dt. So this is a function. We cannot be asked to find the integral. No. We can only be asked to find the derivative of this function, which is the derivative of this. So find g prime of x. Okay. So can anyone help with this? So Victoria, will you help us? If no one says anything, it means that we are either not with me or I don't know. So Victoria, will you help us with G prime?
Is it gonna be
Yes?
f of tx?
You mean sine x, right? That's what you mean.
Yeah, sine x
Okay.
times cos x.
Awesome. Brilliant. Excellent. Wonderful. Good. So I think, thank you so much. Perfect answer. So I'm going to share my screen and go here and let's choose problems. So we are trying to find derivatives. Find the derivative of the function from 9 through 20. We can also do that, but let's choose from 9 to 20. Anything you want. I'll go slowly so you can pick.
15.
Which one?
15.
15. Perfect. So let's start with 15. We have h of x is the integral from 1 to e to the x, I see, natural log t dt. Perfect. Perfect pick. Thank you so much. Where are you guys? Here. Okay. So, of course, we are asked to find h prime. This is the question. We have to make sure that conditions are fulfilled. Is this a number? Yes. Fine. Is this plain x? No. It's a function. Fine. So can anyone else help with this? It's okay if you're wrong. We're just discussing this. So I'm differentiating the left-hand side. I'm differentiating the right-hand side. Can anyone help with this? It's okay if you're wrong.
Is it h?
So h prime. So we are looking here now.
And then is it h and then in parentheses it's ln times ex?
Of e to the x, awesome, times the inner function prime.
E to the x.
Excellent. And can anyone tell us how much how do I simplify this?
X.
Yes, so this is x, e to the x. Brilliant. Thank you very much. Awesome. Well done. Good. Ready for another. And then we're going to look at more complicated situations. Let's look at 19. Okay, so y equals the integral from the square root of x. And I see, is that pi over 4? You can look at the book. Which page was that? Is it pi over 4? Okay, thank you so much, because I'm so far away from my computer. So we have theta, tangent theta, of course, d theta. Nice try. So please correct that. It makes no sense. The function is in theta. You cannot have du. Okay. So please correct that in your book or in your mind. Good. So we are only asked to find y prime. But my integral is no, or my function in the form of an integral is not ready yet. First condition is not fulfilled. This has to be a number, not a function. How do I correct this? Is there a way of correcting the fact that I have the function as the lower limit and the number as the upper limit? Is there a property that I could use here?
Is it the negative sign?
Brilliant. Thank you so much. the integral from pi over 4 to the square root of x, theta, tangent theta, d theta. Awesome. Now all conditions are fulfilled. I have here a function. So I have to be careful and multiply by the inner function prime. I have here a number. Awesome. I'm ready. Can anyone else give it a try? It's okay if you're wrong. So remember, we are differentiating this side and we're differentiating this side.
Is it square root x?
Yes,
tangent
awesome.
Square root x?
Yes, awesome. Times the inner
Square root
function.
x.
Yes, 1 over 2 the square root of x. That's it. And of course, I'm going to simplify these two. And the final simplified form is -1/2 tangent the square root of x. Awesome. That's it. Of course, you can never be asked to do anything else but differentiate a function given to us in the form of an integral. Now, let's also look at a couple of more sophisticated ones, slightly. One more step, and it is an additional step here. So among these, 21 through 24. And then we'll practice some more, but this is fundamental theorem of calculus part 2. Okay, and we'll practice that. But let's choose one other from here. Or we can choose from these. No, from these, 67 through 71. So let's look at one more. Anyone would like to choose?
Number 70.
70, I see it. Good. Awesome. So we're given a function in the form of an integral. We can only be asked to differentiate. X to x squared e to t squared dt. Did I manage to copy from 2 different problems or just from one? I think I copied correctly. Good. Okay, so now I see that the upper limit is a function. The function, I don't care what it is. Who cares? But I have a problem here. This has to be a number. And this is not a number. But there is a property that allows us to split an integral. So one of the properties said that if I have the integral from a to c, I can get from a to b and from b to c. So I can split this interval. You can say, but this is not an interval. This is you have here 2 functions. True. I'm going to treat them in the same way as an interval. And I'm going to say from x to a number, you can put in there anything you want, but it has to be the same number to x squared. Now this integral is okay, but this one is not, but we just applied that property a minute ago. So this is negative from that number to x, e to t squared dt, plus the integral from the same number to x squared, e to t squared dt. Some of my students say, I don't want that. I just want to put 0. Put 0. If you say, no, I don't want to put 0, I want to put 10. Okay, put 10. Nobody cares. We are differentiating. It will go away no matter what. So now I can differentiate the beginning, and this is ready now for differentiation. So can anyone help with this? Negative.
X.
E, there is no,
E,
there is no,
X
there is,
squared?
yes, yes,
E squared.
yes, times the inner function prime, but the inner function prime is
1.
plus. E to x squared squared, but now I have no choice because this prime
2x.
2x, and it's done. You don't have to do anything else. Let me know if you feel like doing another problem, or is this clear? We are applying the properties of definite integrals. Although you can say, well, this is not a definite integral. That's true, it's not. It's a function given in the form of an integral. But we are applying the same concepts. Okay, ready for another one, or we move on?
Can we do one more?
Yes, of course, I'm ready. Choose any.
Does 68 work?
Absolutely. 68 is the g of x is the integral from 1 minus 2x to 1 plus 2x t sine t dt. Perfect. Like before, this function is not ready for differentiation. So I have to write the integral from 1 minus 2x to whatever from t sine t dt plus the integral from the same thing. It has to be the same. You cannot put here 10 and here 15, but it's not going to make any difference, but it has to be the same. 1 plus 2x t sine t dt. I continue flipping this. It's a must. I cannot differentiate if the lower limit is not a number. Good. Now we're ready. Will anyone like to try this?